Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Nabil as a presenter for you today. This video is about to explain to you all the projectile motion experiment for my group. Okay. The introduction for this experiment is projectile motion is a form of motion where the object moves in a relatively symmetrical and parabolic path. In this experiment, we are using the badminton technique, swing technique, and we are trying to prove to you all the projectile motion is occurred to the badminton. Okay. Methodology for this experiment. The first one is to ensure the data is of good quality. Find open space in a suitable environment. Make sure the area you want to make the experiment is no windy. Then place the camera in suitable range and repeat the same technique to get the better result. This all is about prevention we are follow to make sure we have a good data from our video. There may be a lot of effect if you don't follow the prevention when you make an experiment. Okay. This table is shown about the analysis data we got from the tracker. After we get the video, we upload to the tracker, software tracker, and we get the data from the tracker and we make a table from it. This all is from a tracker. We make a 3 different angles for our experiment. This one is the equation we use in at the data analysis. The last one at the bottom of data analysis, we have velocity for the x-axis and velocity for the y-axis. We use these two equations. The first one is for x component. X component, we use x minus x naught equal to px naught times t. For the y component, we use the y minus y naught equal to vy naught times t plus 1 over 2 times acceleration y is the negative 9.81 meter per second square and times time t square. Okay, this is the example from the tracker. This is how we collect the data from the video. We put the video into tracker and we track the shuttlecock from the beginning until the end. And after that, we collect all the data from the tracker and we make a graph in Excel. Okay, this is the first video for our experiment. We are using 24 degree. Okay, the next one we use the 35 degree angle. And then this is the last angle we take from our experiment is 50 degree angle. We use all the 3 video and we put into the tracker and we collect the data from the tracker. Okay, this is a graph from the tracker. This graph is x against t. Okay, we can see from this graph the blue one is 24 degree for 24 degree, and the orange is for 35 degree, and the black one is for 50 degree. Okay, from this graph we can collect the data, the equation from this graph, and then the graph equation Vx naught is from the data. we collect from the gradient of the graph, and the data analysis is from the previous table, data analysis table. Okay, the next graph is y versus t. Y against t. This graph is for the y axis against the time. Okay, from the graph we can collect the data, make a table for the three different angles, same as the previous graph. We collect the same thing, the equation from the graph equation from graph, and the data analysis from the previous data analysis. Okay, right now is the Vx versus time. Vx versus time, the velocity for the x-axis versus time. This graph show about the velocity at the x-axis. Next one is Vy, velocity of y against time. This graph show about the velocity at the y-axis. From the velocity graph, we can collect the data. This all is a slope from the graph. The first one is 24 degree. We got the negative 9.14 meter per second square, and for 35 degree we get the negative 8.66 meter per second square, and then the last one you get for the 50 degree we get the negative 9.64 meter per second square. We got the nearest to the constant acceleration is the negative 8.66 meter per second square, is near to the negative 9.85 meter per second square. I'm sorry. Okay.
For the ST graph, when the angle increase, it will make the displacement become decrease. The increasing of the angle also will make the time become longer. As you can see, for 24 degree, the time is 1.089, but and for the 50 degree is 1.617 second. So we can see that when the increasing of the angle, the time will become longer. And for the y versus t graph, based on the graph, we can see that if the angle is increased, the height will become increased. Same goes to the time. It's same with the graph from x versus t. The time will become longer if the angle is increased. Next, for the Vx versus t graph, when the angle is increased, so the velocity of x will decrease.
Okay, alright. Based on the calculation from the slope of the graph, the slope represents the acceleration. The acceleration is decreased, and prove that the value is reasonable because of it is almost near to the gravitational acceleration, which is negative 9.81. The slope of the graph 24 degree angle, the slope is negative 8.14. The slope for 35 degree angle is negative 8.66 meter per second squared, and for 50 degree angle negative 6.64 meters per second squared. So from the slope of the graph, all the slope is nearest to the gravitational acceleration, which is negative 9.81 meter per second squared. So from the calculation we get the nearest value to the gravitational acceleration is the angle 35 degree, which is negative 8.66 meter per second squared, and followed by 24 degree angle, which is negative 8.14 meter per second squared. For angle 50 degree, it's a little bit far from the gravitational acceleration compared to the angle 24 and 35. This because of maybe of windy surroundings that make this result some error. So the graph for 50 degree angle is not reasonable. Conclusion: based on the result and analysis, we conclude that the result from the graph prove that our test on badminton service technique occur the projectile motion. It is determined by different initial angle that affect its horizontal and vertical velocity. Thank you.